right, so today's the big day we've been getting ready for. Now I'm going to tell you one thing. The only one of the main reasons why we are going to do this for several days is because I want you guys to learn how to think. Think for yourselves. That's it. Can you think? A lot of people just tell me how to do it. Trust me, that's not how calculus works, and that's going to be in 2 years from now. You have to be able to think for yourselves. Okay, so I'm going to give you some ideas. I'm going to give you some hints. So let's go through this together, okay? First thing, when you're verifying identities, what does verifying identity mean? Well, what it means, it's a trig proof. Prove that these sides are equal to each other. That's what verifying identity is. Prove that they are equal. You can prove the right side equals the left. You can prove the left equals the right. You cannot work both sides of the equation. It is not an equal sign where you can move one thing from one side to the other side. You haven't proven that it's equal. You can't move things from side to side. One side only. You get to pick, and I'll give you some hints on which one to pick. Like, pick the most complicated side first. Look for opportunities to factor, add fractions, get a common denominator, things like that. And I'm going to go over some tricks with you. Okay? Some of the things I will go over with you is multiplying by a conjugate. So write that down. Multiplying by a conjugate. And we'll talk about why you might want to do that. Another thing is turning non-fractions. I know this is going to sound weird, but turning non-fractions into fractions. And you'll see why. Usually we don't do that, because who wants to turn something into a fraction? Okay, so your goal, okay, is to prove that the sides are equal. You want to look for fundamental identities. Here's what you also want to think of. Sines and cosines pair well together. Secants and tangents pair well together, and cosecants and cotangents pair well together because of your identities. Last resort, the very last resort, is to change everything to sines and cosines. You don't want to do that unless you have no other option, because usually it takes a 3-stepper and turns it into an 8-stepper. Always try something. So we're gonna have you. I had some volunteers come up last hour and they're like, I can't get it. And they put it up and they were like 1 step away from getting it right. They didn't realize how close they were. Okay, so we're gonna do that here too, and let's see where you're at. But let's go ahead and do some of these together. I'm gonna just kind of show you what you should see. So let's go ahead and take a look at number 1. It says work the more complicated side first. Okay, I have a subtraction on this side and I have a multiplication on this side. It is much easier to turn a subtraction into a multiplication than it is to turn a multiplication into a subtraction, because you're condensing something. So this to me is the more complicated side. Now again, I'm not saying you can't do that side, but what can you do? You can change this to cosine over sine, and then you have cosine squared over sine. Okay? Let's just go with that. Let's see how. You guys bring your erasers today? Let's go ahead and go with that. What does that equal? Now notice I'm doing top to bottom. Proof, like geometry, right? You guys did geometry proofs? We just don't have to give a reason this year. Just one step. Every step is equivalent to the previous step. Would you agree that's cosine squared over sine? My pen's probably going to run out. Look over here. What is this? Isn't this a form of sine? Isn't that a form of sine? Cosecant? Okay, so let's do, I don't know, did you guys watch Sesame Street growing up? Did you? Okay, so here's my question. What doesn't look like the other? What over here doesn't go with something over here? What's the oddball? cosine squared. Is there a way to turn cosine squared into sine squared?
No. 1 minus.
Very good. 1 minus sine squared. Okay. Is there a way to turn a fraction into 2 terms from 5th grade math? Can I turn a fraction into 2 terms? How do I do that? If I multiply by sine over sine, that's going to give me sine squared in my denominator. What else? You want me to factor this? Is that what you said? Okay, all right, so if I factor this, I get sine plus 1 plus sine times 1 minus sine all over sine. So now I have 2 factors, I need 2 terms. What else?
Can you do 1 over sine sine squared x?
Absolutely. Remember from 5th and 6th grade math? Common denominator? Can I do that? So I'm sorry, I'm running out of room here. So if you write big and you want to put this on paper, go right ahead. So what's 1 over sine? What's sine squared over sine? Does my right side look exactly like the left?
Yeah.
I'm done. I'm going to do option number 2. I think the left side is more complicated, so I'm going to start on the left side. Completely new, different problem, okay? We're done with this one. I'm going to pick the left side. How do I combine or subtract things? I need a common denominator of some sort, right? Because I can't just subtract these. So how about we change this to 1 over sine minus sine? And if you don't like that by itself, put it over 1 if you like that better. Now, didn't I teach you how to subtract fractions in one step? Why don't you practice? Lower right, 1 times 1 minus, in this case, sine times sine, all over what? Sine x. And again, I'm now trying to make it look like this over here. Okay, I'm trying to make this side look like this side. So what am I going to change this to? Good, cosine squared x over sine x. Always look to where you're trying to go. I'm trying to go to here. So can I say that cosine squared is cosine times cosine? Can I split up my multiplication? Can I do that?
Yeah.
All right, that's mathematically correct, right? So I'm running out of room, but if I had another step here, I have to write cosine times, what is this? Cosine times cotangent. Looks exactly like this side. I have done the right side and made it look like the left. I did the left and made it look like the right. You get to pick one side that you want to work with. I did it 2 ways. I'm sure I could probably come up with a third. Nobody will do it the same way. Well, every single problem will not be done the same way unless you just copy off your friend. Okay? All right. Elliot, you don't need your computer. You can take that away. Put it away. Thank you. All right, so that's 1. Let's take a look at number 2. Which side do you think is more complicated to work with?
Left.
Then let's do the left. Look at it. We're trying to get to sine squared. Look carefully. Any ideas? What do you think?
Well, that's tan squared.
This is tan squared?
Yeah.
Okay. All right, is this anything?
Negative cosine squared.
Very good, it's negative cosine squared. So why don't we simplify it so we don't have to FOIL, right? Because we don't like factoring or foiling. This is factored. So let's, if you remember I said the more you see, the easier these are?
Yeah.
All right, so you recognize this as tan squared, and you recognize this as negative cosine squared, because it's the opposite of what you want. Now again, what are we trying to get to? Negative sine squared. So what do you think I want to change this to? Okay, there are people who say, oh, that's 1 over cotangent squared. That's true, but is that going to get me here? No.
Sine squared over cosine
Very
squared.
good. Sine squared over cosine squared. I'm running out of ink. Anything cancel? Cosine squares cancel, and does your left side look exactly like your right side? You're done. That's approved. I would not want to work the right side at all. I could, but I would not want to. I wouldn't even want to try. Okay? Let's look at take number 3. Which side has more to do? The right. All right, go ahead and try it. Do something to the right. What am I going to do to the right? Okay, before I change anything to sines and cosines, let's just do some mathematical operations first. So what can I do first? Distribute. Very good, distribute. So cosecant x times cosine x plus cosecant x times sine x. So look to where you're trying to go. If I'm trying to, first of all, what's this?
1.
Yeah, we talked about that. That's 1. So I've got this piece. Can I turn this into cotangent?
Yes.
How?
1 over sine times cosine.
So multiplying by cosecant is the same as dividing by its reciprocal. True? You're done. Those are the easy ones. Any questions? Not too bad, right? Now, all I'm going to tell you is every step that you write down has to be mathematically correct. Don't do any bad math. Each step has to be equivalent to the previous step, so don't drop things off. And most importantly, don't drop off your x's because you're too lazy to write your angles, because I see that a lot. Okay? All right, let's continue. See if we can. Why don't you try number 4? What do you think? Which side has more to do? All right, pick the left then. You want to pick the right? Pick the right. I don't care. I could probably do either one. But I say pick the left because there's more to do. So go ahead and to do it. We're adding fractions. I taught you how to do it in 1 step. I gave you a shortcut for adding fractions. Why don't you try to use it? So take a look at your first step. Adding fractions to get a common denominator in one step. 1 plus cosine beta times 1 plus 1 minus cosine beta times 1 all over what? 1 minus cosine times 1 plus cosine. So again, look at where you're trying to go. What does my numerator equal? Yeah, 1 plus cosine plus 1 minus cosine. What's left? Would you agree it's just a 2? Do you recognize this factorization here? Do you recognize what that's equal to? What is it? Very good. 1 minus cosine squared of beta, which we can also call, what are you trying to get to? What else can we call this? Very good. Sine squared. So dividing by sine squared is the same as multiplying by its reciprocal. Cosecant squared beta. We are done again. Questions? You having fun yet? Yeah, of course. All right, number 5. Pick a side. Go ahead, try it. What do you want to do to the left? Any ideas? I see 2 things that come to mind. Anybody help me out here? What do I want to do on the left? Okay, let's distribute. Let's try that. Tan squared alpha. What is tan squared times cotan squared? Tan times cotan. It's 1. They're reciprocals. So that's distribution. What's that? Recognize it? Yep, secant squared. That's an alpha. We're trying to get to this. What do you think we should do next? What pairs well with sines? Yeah, cosines pair well with sines. So I'm going to change that to that, and I'm done. So that's one of my Pythagorean identities. Did anybody do anything different on the first step? What you got?
So I did tan squared. I set that equals, then I sine squared over cosine squared.
Okay.
And then 1 plus cosine squared
Is?
also equals to 1 over sine.
Okay, hold on, you skipped a step. 1 plus cotangent squared is equal to 1 over sine squared, but that's, you skipped a step on me. What is this equal to? Thank you, cosecant squared. Okay, if don't do steps in your head, write it down, okay? So are we okay with seeing this is this? Okay, so then you told me that sine tangent squared is sine squared over cosine squared. And then you were trying to tell me that. So gets me to the same result, doesn't it? So there's option number 2. know you love options, right? Let's do option number 3. Let's work the right side. Let's work the right side. I'm trying to get to this. What is this in the denominator here? Yeah, so that's 1 minus cosine squared of alpha, right? And what's, again, I'm trying to get to this. So I'm going to change this to secant squared alpha. And then I'm going to change that, again, I'm trying to get to tangent and cotangent. How is cosecant squared related to tangent? It's tan squared plus 1. So I need it in factored form. So how about I just pull out a tan squared? And I get 1 plus, when I pull out a tan squared, I get 1 divided by tan squared, which is, so I just made my right side look like my left side. It's doable. I certainly wouldn't choose to do it that way, but it is doable. I like 1 and 2 better, but there's no wrong way to do it unless you do something that's mathematically incorrect. Okay? So there's 3 options. All right, number 6. We're moving along pretty good today. More complicated. Kind of look the same to me. Kinda. What do you think? Which one, left or right, is more complicated? Why did you pick the left? Why not the right? Yeah, the right is basic cosine, right? So it's got the basics. So the left is really more complicated. So let's work with it. Okay? Again, let's play Sesame Street here. Which one of these doesn't go with the other? Which one doesn't pair well with cosine? Tan. So some people say, let's change it to sines and cosines. Okay, but are there any sines over here? No. So let's pick something else. Secant squared x minus 1. That's a good idea. Because secant is a form of cosine. So I'm almost to cosines. Bad math is canceling the secant with the secant and canceling the 1 with the 1. That's bad math. Give me some good math. Your favorite F word. Factoring. All right, that's your favorite F word? Or is that your second favorite F word? Your first one is factoring, isn't it? Your second one is fractions. That's right. How do I factor a difference of squares? Secant plus 1 times secant minus 1. Difference of squares. Does anything cancel? Yeah, the secant, this secant plus 1 is a factor. 1 plus secant, those are exactly the same. So I'm left with secant of x minus 1. I'm getting closer. I'm trying to get to here. Any ideas? Okay, let's do that. Let's change this to 1 over cosine. What should I change this to? If this is 1 over cosine, what do you think I want that to be? Yeah, cosine over cosine, because we need common denominators. And then how do we subtract fractions? We have the common denominator, true? So top minus the bottom all over the common denominator. And is the left look exactly like the right? We are done. Do not stop until they are identical. Told you we were going to have fun today. All right, I want to show you a trick while we're here, okay? Let's go to this step right here. The secant of x minus 1. Everything else is the same. Let's get to this step right here, okay? This is a trick that you wouldn't know about unless I told you and you worked on in this for 26 years like I have. Well, probably longer than that. But here I have a binomial with no denominator. Here I have a binomial on the top and a monomial denominator. So here is where, if one side doesn't have a denominator and the other side does, make the one without the denominator you want. So wouldn't it be nice if I'm trying to go from this side to this side, I'm at this point with no denominator. So can I multiply to make it have a denominator? That's a trick. So I'm at this point, I'm comparing it to this side, no denominator, denominator. Let's multiply it by what we want it to look like. And what happens when you do that? How do I multiply these together? Let me give you a hint. How do I multiply those numerators together? Distributive property. What is cosine times secant?
1.
Did I get to the same spot? That's a trick of making a non-fraction a fraction. And that's why you would want to do something like that. Little trick. Okay? All right, so we're doing well. All right. Number 7. Pick the more complicated side. They look about the same to me, right?
Right.
That's right. Now, people say, oh, well, this is a fraction equal to a fraction. I'm going to do cross multiplication because that's what my 6th grade teacher taught me to do. This is not equal yet because you haven't proved it. You pick the right or you pick the left. Your choice.
Right.
All right, let's pick the right. Really not a whole lot we can do with that because it's already done, right? So let me give you another hint that I had you write on your paper. Multiply by conjugates. Now here's why. Here's what I see. I have a 1 minus sign here. I have a 1 plus sign here. I know because I did my homework that that's a linear factor from one of my Pythagorean identities. Isn't it? Isn't that a linear factor from 1 minus sine squared? So the trick here is to get one of these, if you want to work this side or you want to work this side, to get that to one of your Pythagorean identities. Now let me tell you bad math. 1 plus sine is not equal to cosine. That's not true. 1 minus sine squared is equal to cosine squared, but the linears are not. So here is the trick. If I see a linear factor, this side or this side, of one of my Pythagorean identities, I'm going to multiply it by its conjugate because I can make it a Pythagorean identity. Again, that's a trick that you would never know if I didn't tell you. Okay? So how does that help us? Again, numerator times numerator, you should know that that came from, or that is the factored form of 1 minus sine squared. Right? Maybe we leave it in factor form, I don't know. So now the denominator, and if you recall, I said this the other day, do not distribute in your denominator because many times, one of your factors in the denominator will cancel out. So don't multiply the denominators together because you might have to factor them later on. So we're going to hold off on the denominator. All right, let's see where we need to go. We're trying to get to here. Any ideas? Cosine squared where? The top, the numerator. Good. And what happens? How does that help? What can I do? Can I cancel these factors? Yep, and I have one left on the top. And I'm done. Option 2. Let's work the left side instead. You guys try that one. Same idea. You work the left side. We're going to make the left look like the right. Forgot which side I was working. There. All right, so it's either or, it's not both. Ready? Multiply by the conjugate because this is a linear factor of our Pythagorean identity. You can replace that. Again, I'm trying to get to this here. You can replace 1 minus cosine or sine squared with cosine squared. One of these will cancel. I've just made my left side look like my right side. They're about the same, right? You don't have to do both. You do one or the other. So I think these are the right side or the left side is about equal on this one. All right. Ready for number 8? All right, I want you to think a little bit. Go ahead and try number 8. You pick the side. Completely up to you. Think about all the tricks I taught you. Just give her a try. Try something. Learn from failure. Anybody want to get me started? Anybody want to pick a side? Again, there's no wrong answer. What's mathematically incorrect? Help me out, Deanna. Pick a side. This side? Okay, what do you want to do with it? So you want to change this to 1 over tangent t? Okay, let's go with that. Okay? Is that it? What else? What do you want me to do next? So tangent t minus 1 over tan t? So I can't cancel anything, right? I mean, it's not wrong, but I would have to combine fractions, and I have to divide by this. So I'm going to avoid fractions within fractions whenever possible. It's not wrong. I'm going to try something else because I think it might take me too long. It's not wrong. So that's a start. Anybody else want to work the left side? Anybody? Let's stick with the left and then we'll go to the right. Anybody else want to work the left? Okay. Me. I think we've already talked about this. Can I split a fraction into 2 terms? Aren't I allowed to do that? Yes. So I have to look over here. What am I trying to make it look like? Well, I have a monomial, and I need to turn it into a binomial. So let's split it up. If you don't want to do it this way, that's fine. You can just watch. You don't have to copy it down. So I need to make this look like this. I need to make this look like this. So always look ahead. I'm trying to make this secant squared. Any ideas? Okay, so tangent is sine over cosine, and then I have, and I'm going to split this up, and some people don't like this, but tangent here, right, tangent here is sine over cosine, and my denominator, I can split it up like that, right? I could do that. What cancels? Yeah. The sines cancel, and I'm left with 1 over cosine squared. I can't forget about this guy here. We're going to do the same concept, right? We're trying to get it to be cosecant squared. So what's cotangent? Cosine over sine. And again, I'm going to separate my denominator just so I don't have a fraction within a fraction. What cancels on this one? And dividing by cosine squared is the same as multiplying by secant squared. Dividing by sine squared is the same as multiplying by cosecant squared. Now I did it 2 different ways last hour, and this was not one of them. I saw something different. Now it sounded like the majority of you wanted to do the right side. Okay, let's go with that. What do you want to do to the right side? We have secant squared t minus cosecant squared t. That's what we have. What do you want to do with it? Do you want me to change this to tan squared plus 1? I could, but again, we're trying to get to this. You want to change it to 1 over cosine squared? And change this to 1 over sine squared? Okay, we could do that. What else could we do? I like my trick. Again, it's personal preference. I like my trick of making it a denominator that you want by multiplying a non-denominator by a fraction. Again, that's just personal preference. Not that yours is wrong. So for those of you, again, the problem is some of you don't know how to multiply these. So this sine t, cosine t, this is not foiling. This is one term that we're going to distribute. So we're going to get secant squared t times sine t cosine t minus cosine squared t times sine t cosine t all over sine t cosine t. Now again, looking ahead, do I have the denominator that I want? So that means this numerator has to simplify to this somehow. You can't just tell me it does. You have to show me it does. Any ideas how to show me? Let's work on this piece right here. How can I turn this into a tangent? What do you think? 1 over cosine squared. That would be a good idea. And this is a lot of writing. These lazy people aren't going to want to write all of this. But that's none of you, right? All over your common denominator. Every step has to be equivalent. So Megan wanted to turn that into cosine squared and 1 over sine squared. What does that do for us? Let's work on this one. What do you see? This cosine cancels one of these, and what's left? Sine over cosine, which is tangent. How about this? What cancels over here? Sine cancels one of these. What's left? Cosine over sine, which is cotangent. And we just made our right side look like our left. So we're done. Now again, maybe you approached it differently and got to the same result. That's okay. All right, we have 2 left. I'm going to have you work on them by yourselves. Okay, and then we're going to call some people up to the board to look at their work. And if it's, even if you don't get to the answer, that's okay, because we can learn a lot of things from people's ideas. And you'd be surprised at how close you are. All right, so I'm going to turn off this recording for those of you who are watching this at home. Go ahead and try the last 2 examples, and then you've got a homework assignment.